Hello, everyone, and thank you very much for our second attempt at testing pulp using the new Pytest Fixtures session with Brian Bouterse. I very much appreciate all the feedback from last time that let us knew that there were issues. Hopefully there will be less issues this time, but if there is so, just let me know as quick as you can. If you have any questions at any time, feel free to use the live chat here on the YouTube panel or on Matrix. If you at core, I will see it straight away. And I don't have anything else for the moment. There will be another session on Wednesday, a follow-up to this. So without further ado, I will hand you over to Brian.
Thanks, Melanie. My name is Brian, and I'm going to be talking through the way to use the new Pytest fixtures to improve the testing of pulp. And like Melanie said, this session has been split up into kind of two halves. And so this is the first half of the content in this slide deck. And then we'll get the second half on Wednesday, I believe is our time. So the proposal here is to have all new tests written using Pytest and its features. My goal with this is to kind of unpack how to do that, to enable folks to understand, hey, these are like the 3 or 4 steps that I should take to start doing that. And right now we use unittest as the kind of testing framework for most of the tests. And for every new test that's written, eventually we're going to go back and kind of rewrite our tests to use Pytest. So I'm hoping that we can stop writing unit test-based tests because then we're going to have to go back and rewrite those later. So that's my hope, and that's my proposal for the pulp project generally. This is some of the basic stuff that we're going to go through today. This is the agenda portion for today. We're going to look at how to make your test discoverable by Pytest, how to make a home for your Pytest fixtures, and how to use fixtures to generate bindings objects, and how to use Pytest fixtures instead of the kind of setup and teardown patterns that unittest provides. And then we're going to look at using assert instead of assertEqual, which makes your test code assertions cleaner. So this is a look at the fancy stuff. This is a little bit of a preview for next week, but I'll just briefly call it out. So the focus for next week's talk is going, or I'm sorry, for Wednesday's talk, not next week, for Wednesday's talk is to look at the new local fixture server. This is a Pytest fixture that serves up fixture data. So that would be like files that pulp is going to sync from or sync. And we're going to make assertions on the server calls that Pytest, that pulp is syncing from. And then we're going to show off the new parallel test running functionality. So all these topics are going to be happening on Wednesday. So why are we doing this? I just want to level set what the motivation is here. We had a video and discussion back on at PulpCon, and this is a link here, and you can hopefully see all these links yourself. So if you want some background, there's like maybe a 30-minute motivational talk about some of the details around the motivations here. But this is a 4-point summary, more or less, of why are we doing this. One of our goals is to keep the data fixtures. This is the data that Pulp's functional tests assert against. So like we'll download some of these data fixtures and then assert that their checksums are a certain way and that we can copy them between repositories and things like that. So we want to keep fixtures with the commits that use them in one repository. And we don't do this today. Right now, we have a fixtures repository and the code that uses them, and the fixtures, the data fixtures that are synced down by the functional tests are in different places. And so we want to keep fixtures with the code so that we can version them. Right now, we struggle because the code gets versioned over time, but the data fixtures don't. So we want to version our data fixtures. We also want fewer commits, so it would be great to contribute and update data fixtures in the same commit where you write test code. So we want to keep them in one repository. And by having them in the same commits, we can make them cherry pickable to other source trees, like downstream source trees, or anywhere where pulp is being kind of compiled, not compiled, but kind of kept in one place. So we want to make them cherry pickable. We also want to make the test suite easier to run locally. So right now, the test suite is more or less welded to use fixtures.pulpproject.org. And we want to make this run locally. And using the new Pytest Fixture web server, which we're going to show off on Wednesday, you'll be able to do that. Also, we want to make assertions from the web server that Pulp is downloading from. There are some aspects of Pulp's correctness that we currently can't test because the receiving end of Pulp's downloaders is not something that we have control over at test time. So by doing it in this other way, we'll be able to have a better tested Pulp through better assertions around Pulp's network behaviors. Also, we want to have less test code, but at the same time, we want better test code. And this is really the point that we're going to focus on today, because using Pytest, I believe, is a great way to have more concise and better test code. I want to start off actually with some thanks. I want to thank Matthias Delweg, aka X9C4 in the channel, for a lot of collaboration and discussion around this. I hope you can see his signature in this work for all the great thoughtful discussions and ideas that he contributed through this. I'd also like to thank Pytest, AIOHTTP, and the Trust Me communities for making great software that we use here. There's some language issues. These are English language issues. Fixtures, this is a complicated talk because fixtures here have two meanings. So there's a Pytest fixture. Pytest fixtures help create conditions for test assertions. And we'll look at some of those if that's not clear. There's also a data fixture, and this is data that is served to Pulp via web servers, and the Pulp downloaders download that data. So I'm going to try to use, every time I say the word fixture, I should say either Pytest fixture or data fixture, and if I'm not, it's because it's complicated, so please do ask for clarification. So let's get into it. The first thing here is to name your tests so that Pytest can discover them. And so you can prefix functions or methods with a test underscore. And here's an example of that. I'll make this font real big here. So in this module here, this is in pulpcore, I've converted, this has like maybe 15 tests, and these are already done in the Pytest style. And so here you can see the tests are not in classes, but it supports classes too, if that's what you would like to do. But in order for Pytest to discover them with its default test discovery defaults, you want to have a test underscore at the beginning of it. So test underscore and then the test name, test underscore, test name, test underscore, and so forth. So that is the way to have your test discoverable. You can also have them under classes. I don't think I have an example of one of those, but the Pytest docs certainly do. You want to name your class with a capital T, test. And this should be the first word of your class name. And then Pytest is going to look at that, and it's going to say, oh, this has test code that I should run as individual tests. You can see the official Pytest docs here that I'll link to, which talk about the conventions for test discovery. So, they have more details here and how you can control it. We don't configure any of these things any differently with Pulp. So if you stick to the recommendations here, which I've more or less summarized, then your tests too will be discovered. So adding Pytest fixtures. So these are Pytest fixtures, which is a feature of Pytest, which each of these fixtures is designed to help create some sort of a configuration or condition that your test code can run in or against. And so fixtures are run before your test code, and they also can include teardown of objects as well. So you're likely going to want in your plugin, for example, to have a place to put your Pytest fixtures. And So what I recommend doing, there are various ways to do this with Pytest, but I recommend adding in your tests folder a conftest.py module. And this is Pytests, they expect this name and they search for this name. And this is going to let Pytest discover your fixtures. And so let's take a look at the example here. So this is in pulpcore. Pulpcore's got is already starting to use this setup. So a lot of our references and examples will be from pulpcore. But you can see two files here, and this is in the main top level tests folder. So pulpcore.tests. And there's a conftest.py. This is what I recommended that you create. And notice, oh, look, there's only one line in here because it actually kind of chain loads this other file, which is up here to this file. It's conftest_pulp_file. And this is where all the actual fixtures are in this case. You can use these subimports to kind of organize where your fixtures are. And what we're going to be doing today is going through like, what do all these fixtures do? But right now, what I'm trying to share is that you want to put them in a conftest.py, and you can organize them with subimports, just like what you saw there. So one of the objects that you deal with a lot in Pulp's test code are bindings that are generated from the Open API schema. We want to use bindings instead of a library like requests or some other raw HTTP library, because when we use the bindings, we can assert and rely on additional correctness that the bindings themselves are correct. And so we always want our tests to be bindings based. Pulp has been doing that for, I'd say, about 18 to 24 months at this point. So that shouldn't be really new to anyone who's worked with Pulp's test code. So, but what is new is that the way that we generate those bindings, instantiate those bindings objects, would be improved if we did them as Pytest fixtures. So the bindings for pulpcore objects, things like tasks or Orphan cleanups, or the really general pulpcore, the base pulpcore bindings, those need to be available in all the different pulpcore and all the different pulp projects and all the different pulp repositories. So rather than putting them in pulpcore, we actually put them in pulp-smash. And because they're in pulp-smash and the CI and everything uses pulp-smash already, you'll get these fixtures. You already have access to these fixtures, actually. And these are Pytest fixtures. So this is a very basic example of a Pytest fixture. There are two of them here. One of them is the pulpcore client, which returns an instantiated API client. And then the other one, this is an example of the tasks API. So you probably, there are other ways to generate these bindings in pulp-smash, but this is the Pytest style option. And these are set to scope equals session, which Pytest fixtures have different scopes. And what the session option means is that this fixture will be run exactly once for the entire test run. So it creates very long-lived objects, which is more efficient than generating them test by test. And we can do that because they're more or less stateless. You can do whatever you want with these objects, use them how you would normally, and it's fine to have them used in another test and then another one after that and another one after that. And so we put this scope equals session here. The default scoping of Pytest fixtures is, if I remember correctly, called function scoping. And that means that fixture will, and the objects it generates will be run before every individual test. So that's what scope equals session means. And also you can see here with this decorator, this is how you declare something to be a fixture. You can name it whatever you want. There isn't a naming convention here, but it is important to declare it as a Pytest fixture. And in this case, it's going to be returning an API client and returning a task API. And so in my test itself, if I use, say, this fixture's named pulpcore_client. So if in my test I have an argument called pulpcore_client, then I'm going to receive the value that's being returned here. So this is a way for your test to state, I need and rely on this Pytest fixture, and Pytest figures that out when it goes to run your test, and it knows, oh, I need to run these fixtures and save the values they generate and hand them to an individual test. And so we'll see more examples of that, but I'm trying to give a high-level description of just how do these fixtures relate to our tests. So here what you've just seen is the bindings for pulpcore objects, specifically the base API client and the tasks API, are generated from fixtures that are available in pulp-smash. And so you don't need these other like utilities. You can just have them received from those fixtures. I explained session scoping here. For the bindings objects, you probably want session scoping for all of those. And you should expect to make bindings Pytest fixtures, or should I say Pytest fixtures that generate bindings objects for your plugin. So let's take a look at some of the ones for pulp file. These should be kind of much more relatable, I think, because for your plugin, like whether it's Pulp Ansible or Pulp Pream or something like that, Pulp Debian, you're going to likely want to generate a repository file API. This is the object for dealing with file repositories, or the remotes file API. This is the object for dealing with file remotes. And so these all look pretty similar in the sense that they are simple session fixtures that generate bindings objects. And the only one that's a little bit different is down here, line 40, which uses this helper function called genObject with cleanup. And I think that we'll talk about that in more detail now, if I remember right. Yeah. So one of the helpful facilities that have been made is this genObject with cleanup. What this does, you can see this here. This is another one of these Pytest fixtures. So literally just by saying, oh, I want to use genObject with cleanup as a named parameter to your test function, you'll just have access to this. And it will have already run. And this uses the yield style Pytest fixture, which you can go look at the Pytest docs to see more about. But the idea here is that prior to your test running, if it needs this Pytest fixture, will run down through lines 236 down through 244, which generates this kind of anonymous function and returns this anonymous function. And the object that your test code is actually getting is a callable function. It's this one. And your test code runs here effectively here at line 244. And when your test code is done, the rest of this code runs. And that's how these yield style Pytest fixtures work. And these provide cleanup. And so this helper function's goal is to let you create objects and it will automatically clean them up. And this is I think a much cleaner alternative to creating what we do today, which is like we create an object and then we have to specifically call it to be marked for deletion. And there's kind of unit tests set up and tear down boilerplate. It's kind of like in a zillion places. So this is the replacement for that. But this is probably a little bit confusing. I know I would be confused by it. So let's look at an actual example of usage, because it's not really important how it works as much as it is how to use it. So fixtures, Pytest fixtures can rely on other Pytest fixtures. And Pytest figures out kind of the call order to generate them in the right order so that it can make it all the way through. And so this is another fixture itself, but in either case, whether this was a fixture or test code itself, the way that it's asking for the Pytest fixture is the same. All it has to do is include it by name here as an argument. It doesn't have to import it. It doesn't have to do anything like that. Pytest knows that Pytest fixtures are the parameters here. And so it says, do I have a Pytest fixture named gen object with cleanup? Oh, I do. And so let's see how this is used. In this case, we're making a remote, and we want that remote to be auto cleaned up. And so we are generating a function. This fixture itself is a function. So when my test code goes to use file fixture gen remote, it's going to also be getting a callable function. And that provides an opportunity to pass in a fixture name and a policy and some other arguments and things like that directed from my test code. But regardless of that, I want to highlight the usage of gen object with cleanup, which is when I call it, it gets the API client. So in this case, the file remote API client. And it takes keyword arguments that were passed in by the test code as it called this kind of factory function. And after the test code runs, if I called this once, or if I called this twice or 3 times or any number of times, it tracks all the objects that were generated, all those remote objects, and it deletes them upon cleanup. And that kind of happens all automatically. So I'm sure it's confusing, and that's unfortunate, but the upside is huge, which is that you can use these to just call and generate objects where all you have to really provide is the API bindings client that you want to use, and then the keyword arguments that you would use to configure the object that you're creating, and you get that object, and you also get this great auto cleanup functionality. So next, that's the example of making the remote. I want to show, just to connect this, so let's actually see this used in a real test. So it's that same kind of pattern where, Pytest knows that this is actual test code. Each of these named here are Pytest fixtures. And we were just looking at file, let's see what we're looking at, file fixture gen remote. So this is to generate a remote that's used for file fixtures. And we pass it some keyword arguments to help configure that remote. And this remote on demand is an actual instantiated remote. And then after the test completes, this remote will be deleted. So that's a look at how to use it. This is a well-established pattern in Pytest, which it looks a little bit awkward, this kind of anonymous function situation, but it's a well-established thing. It's here in their docs. It's the factory pattern to produce fixtures. And the reason this is used at all is because if you want to pass in data to your fixture, and that data is in your actual test code, like in this case, you want to instantiate a record for Lisa and Mike and Meredith. If you don't have an opportunity to call that and pass in that data with the typical usage of Pytest fixtures, because this make customer record, yes, it's a Pytest fixture, but I can't pass data into it. I can just use it. And so that's where you use this pattern where you define a function. That function, that kind of factory function, is what's actually returned. And then you can call that factory function any number of times, passing in additional data. So this is anytime that you need to pass in data to your fixtures, just as a general rule, you should be very likely following this factory pattern. And that's a lot of what you've just seen here in terms of Pulp's usage of it. There's also the Orphan cleanup fixtures. So a lot of the functional test code does Orphan cleanup calls, and what you'll see kind of all over the place are these delete orphans calls. And so we want to still have that happen, but we don't want to have to keep writing this boilerplate in so many places. And so there's this delete orphans pre-fixture. It's very simple. This is another one of those pulp-smash fixtures. So in your code, all you have to do is say delete orphans pre, and you will get this functionality, which it calls delete, or the pre here means that it's deleting orphans ahead of your test code. And so you delete orphans, and then yield, which yields control to your test. And so this will delete the orphans for you. And let's look at this example, which actually uses it. So here you can see delete orphans pre is one of the named Pytest fixtures that it depends on. And so this test will delete orphans prior to running. And that's a function level scoped, the default Pytest fixture scope is function level. And so this will run, this fixture will be generated or called and generated for every test that uses it uniquely. And that means that if this test uses it, this test gets an orphans deletion call prior to it. This test also uses it. This test gets a separate and different orphans deletion call prior to running. I think this is the last topic for today's session, which is using the assert statement for the win. So the idea here is to stop using unittest.assertEqual or assert greater than, less than, dictionary in, blah, blah, all these like long assert calls. They're difficult to read. And because they're difficult to read, they're not as great as something that's simpler. So Pytest allows you to actually literally use the assert keyword in Python and then just assert whatever you want. In this case, I'm mostly just making quality assertions, but this is an actual in usage here. But you can use this to evaluate any sort of expression, Python expression, and assert is going to raise an exception if that fails. Pytest is really slick about this because normally when you disable Python's, like when you run the Python interpreter, you can run it without checking these assert statements, which was one of my concerns. But so I forget who, but someone pointed out to me that Pytest as a project actually reads the Python code and effectively rewrites these statements to be a longer version equivalent of it. And so my understanding is that even if you run the interpreter to not look at these assert statements, the Pytest assert statements that are in Pytest code, just like this is in a Pytest test, these are still going to raise, and that is very slick. So it is, what I'm trying to say to you is, it is totally safe in all cases to use assert, and that makes for better, shorter tests. So let's do that. All right, this takes us to the local fixture server test, which are a whole set of Pytest fixtures, which will set up and run web servers that the test code can then sync from. And that is the topic of our next session on Wednesday. So I will stop us there.
Okey-doke. Thank you, Brian. So far, I do not see any questions for you today anywhere. So I think we should be about caught up. There's slight latency with the feed. So if there are any questions for Brian after we finish now, please write to us either on our community discourse or on Matrix. And we can allow 1 minute maybe. Let's see. Is there anything else?
Yeah, I mean, just since we have 60 seconds here, I will say, just like you're saying, Melanie, please do. This is confusing stuff. It's it just it is, but it's also very powerful. Creates very powerful outcomes, and so please do come and ask questions about it. If this didn't make any sense at all, that's a fine thing to share. And let's keep talking about it. And come and ask me. I'm being Bouterse in the Matrix channels, and I really want to support others' development to switch to this testing style. And so come and talk to me about it to better understand what I've shown today or to give feedback on how it can be improved.
Okie doke. Brian, thank you very much for your time. And thanks to everybody who watched along with us today. Please let us know what you thought of this session, and we will see you all again on Wednesday, not next week, this week. So thank you very much. Take care.
Thanks.